Okay. So, are there any questions so far? I mean, about past material, obviously, right? Yeah.
For this assignment, do you want us to make the boxes just square?
I don't care too much. They can slide even if they're rectangular, after all. Okay, so, I mean, you can make them square. But the way to make them square would be to set their size as via CSS to a fixed number of pixels, right? But you don't have to do that. Okay. Okay, so what I want to do is to start work that goes towards the homework 6 and solve one of the main problems of CS, playing tic-tac-toe, okay? So what I want to do is making a very simple app, which we will see is, I hope is interesting, to play tic-tac-toe between two different handsets, okay? And the homework 6 will consist in you writing an app instead to play battleships between two handsets, okay? So one of our TAs kindly made a function that will enable you to get a randomized distribution of ships within the board, okay, which is, a little bit of a boring thing to do, I guess, so he was very kind to do it. It's a sort of, it's hard, but it is not that hard. It's the non-conceptual portion of the play, okay? And instead what you have to do is something similar to what we do here, that is take care of the synchronization between players, okay? So that's generally what we will be doing. I don't have my code ready. I cannot simply walk over the code with you. And this is also because I think it would be a little bit boring if I came here with the code entirely ready and just I walk over it. I want to have a little bit of fun, perhaps, trying to decide some of the code. And while I start, I want to tell you something about the philosophy with which I'm going to write this code. Let me just check that. Hey, where did the window go? Oh, boy. I just wanted to check that this is actually framing the board, but I hope it is. I want to record on the board. So there is a general issue in this assignment. That is, we have two different phones, and we have to make them play one against the other. Okay. So what kind of information are we going to send? And how are we going to do it? So the first thing is this. We obviously are going to use a server, right? So all this phone-to-phone communication often and usually is mediated by a server. Is not really direct. There are on the App Store some apps that do it directly using Bluetooth or other things. But in this case, we will do it based on servers so that you can play even at a distance, okay? One of the fans of these distributed cloud computing is the fact that in fact is not that distributed, this mobile ecosystem, when it comes to communication. So all the communication is in the end always mediated by some central server, typically. So the other thing that, what are we going to send? And you can imagine that as we play tic-tac-toe, we might be sending, I play in A1, no? Where you say ABC, 1, 2, 3, and you give the coordinates of where you play. And that's not what we are going to do, both because it's not a good idea and because of sort of general philosophy. So the problem with sending a move is that the move may get lost. Right? We are in a mobile environment. I can be, getting into the elevator, the door's closed, it's metal, and so my signal doesn't get out, there is a timeout. Or simply, you take a turn on Highway 17 and you're not covered anymore. There are many cases in which your phone loses connection, right? And so I don't want to depend on sending moves as they can get lost. This is in fact, and I have every year a little bit of fun introducing the topic in this way, this is in fact a general problem in designing communication mechanisms. You have in general two choices, broadly speaking. You can choose to send changes or to send state, okay? And I want to argue that changing sending state is the superior choice. The problem with the sending changes is that changes can get lost, and once they get lost, it's difficult to reconstruct consensus. In fact, what I want to show you is that you can never achieve consensus by sending state signals, by sending change signals. Let me give you the demonstration in general, because it's a fun fact, and the proof is so easy that I think everybody in computer science should know it. Assume that you have two different servers, or two different computers, or two different entities, right? And you try to achieve consensus by sending back and forth messages. For example, I send to the other thing this, and the other person says, acknowledge. And then I say, okay, but does the other person know that they have received it? And so I send, I acknowledge of your acknowledge. Let's imagine it in a more human setting to bring out the question. There are here two people that, following the tradition, I call Alice and Bob, the traditional names. And and they have to decide whether to go out to the movies or stay home. Okay, so they live in different places and they can send each other asynchronous messages. And the point is that these two people would like to achieve consensus. They either would like to go to the movies together, or they would like, to stay home and read each one in their place. But they don't want to be stood up. They don't want that one of them goes to the movies and the other one doesn't show up. Okay? And so they are trying to do this by sending each other messages. So we imagine, because otherwise there is no consensus problem really, that each one of these people has a set of two choices that they can take. That is, read and movie, for instance, R and M, and each one of the two has these two choices, okay? And we imagine that in an initial configuration of the problem, so this problem can be, this protocol can be run many times, but both R and M are possible choices for the initial states of the two actors, okay? If one actor has only one choice, then really the protocol would simply say, take that choice and that's it, And so we want a protocol that at the end of running by sending around messages has this property, okay? That it achieves consensus, that is, that both of these two people get the same choice, say RR, they both stay home and read, okay? But also that the choice they get is one of the initial choices for at least one of the players. This seems like a funny requirement, but it's because otherwise I tell you what is a consensus algorithm. Stay home and read. It's a silly consensus algorithm, right? Because the choice is fixed independently of the initial wishes of the two participants. So no information gets communicated. So that you can do, obviously, right? But here we want a protocol in which there is some initial communication, there is some communication of information. The two actors have some initial preferences, and then they have to, somehow do whatever. But the state of agreement has to be the preference of at least one of the players. So, for example, we can do it so that, whatever Alice prefers is what will happen, okay? That's an okay way in which we might design the protocol, because then at least the outcome will be the wish of one of the two players. Or we can do more sophisticated things. But what I want to show you is that, in general, there is no such consensus protocol that you can ever write if the communication is asynchronous and if messages can get lost, which are essentially, the two things that happen in a mobile environment. It's asynchronous because, there is no global round of communication between the participants. The phones send information when they want, and messages can get lost because you can lose your connection altogether, okay? So how do you show that it's not possible to have a consensus protocol between these two? The proof goes as follows. Imagine that there is one, and so there is Alice that sends a message to Bob containing something. I don't care about what it contains. My argument is completely general, okay? So it sends some message to Bob. Bob sends some message back. This goes back, this goes back, and after a while, let's assume after this message, we assume that consensus is reached. So they both have a configuration X, okay, where X belongs to the set of, R and M. That is the same for both of them. And they both know that that is what is going to happen. So they send each other these messages like, I want to go to the movies. Okay. Yes, I got your okay, so I'll really show up. Okay, I got it. So, let's see you at the door. I mean, whatever they do, right? But they send each other back and forth these messages. And consensus is achieved. So assume that this is possible. How do you, what we want to do is a reduction towards a contradiction, okay? So look at it this way. If this is possible, at this point, Alice has essentially decided that the consensus will be X and will be sending the last message to Bob, okay? Now, this when Bob reaches that message, Bob also achieves the consensus that the choice of both of them is going to be X. Okay, that's what the protocol says. I mean, the protocol needs to terminate, and when it terminates, that's what happens by a hypothesis, okay? So the problem is this, that this last message might get lost, okay? So the fact is that Alice needs to commit at this point in time that her choice is going to be X. She will not know anything further out of Bob. Bob, this is the end of the protocol. Bob does not reply back. Okay? So at this point, Alice will commit to X. This is quite clear, okay? Even if this last message is missing. Okay? Because it could be missing. Fine. Now reason backwards. Here is Bob. Bob is about to send his last message. Bob is not sure that the message will be received, right? But Bob also knows that if the message is received, Alice is going to go into state X, believing that X is going to be the consensus. Because Alice cannot revise her opinion beyond this point. So Bob, at this point of the protocol, says, okay, fine, if I send this message, whatever it is, Bob will go into consensus X. Alice will go into consensus X. Okay? So at the point Bob sends the message, Bob has already have decided X. There is no other way, right? Because Bob cannot wait to decide X here. Bob may not hear back from Alice because, this message might get lost. Or this might get lost, for the matter. Bob is about to send a message that will make Alice commit to X. And Bob does not know whether the message will make it at all, or whether he will get any reply. So at this point, it's like the two spies that send each other messages, right? So at this point, maybe with spies it would be better, than with movies. It would sort of bring out the choice more, They have to leave the piece of paper in the Dropbox, and somebody's gonna... So at this point, before Bob sends the message, Bob needs to decide on X already. Yeah, I'm sorry. I think I should do this, right? And then I should aim this higher. Always aim higher. Haha, sorry. Okay, so at this point, Bob has already committed to X, and this message, might get lost. And now I think you see how the proof goes, right? Because the problem is, look at Alice here. Alice is about to send a message to Bob. Alice knows that once Bob gets that message, Bob will need to commit to X. Okay? Because Bob, when sending back the message, is by induction. We have already done it, right? So at this point, Alice knows that when she sends this message, she's committing to X, because she may not hear back. Okay? Because of this chain of reasoning. And so you go this way, and essentially, you can show that X must have been the initial choice of the players. But then that's not possibly a consensus protocol, okay? Because you cannot make sure that X depends on the choices of both players. So essentially, Alice must commit to her choice before even knowing what the Bob's preference is. And Bob may not even get Alice's message. Okay? So in general, you cannot achieve consensus by sending back and forth information. So what we're doing is another protocol in which we send repeatedly state. Let me give you another example of the difference between the two. Imagine that you're doing, and also how to convert a message, a change protocol to a state-based one. Imagine that you have to send, that you want to be reimbursed for something you do. And so, this doesn't go down, right? No, it doesn't. So you start to make a list of your expenses while you are on a travel or on something, and you write an app that tells the server, oh, I spent $12.98. Okay, and you send it to the server, and the server will tell you ACK, and then you say, oh, okay, I got your ACK, and you try to, and we know that this is hopeless already. And then you want to say that, oh, I spent now $6.59, and you want to send them one by one. This doesn't work, right? We cannot send change messages to the server. Also, imagine this fact. In our worksheet, there is a server. I tell him I spent $12.98. He doesn't reply. I mean, he replies. He marks it in the database, but his reply to me gets lost. I mean, this is entirely possible. When you do a post request, right? There is a communication protocol in which I do the post request, he's processing the post, and at the end of the post, he generates the answer, right? And there are several moments in which this can go wrong, right? For example, his code may contain a bug. So he can first record the response in the database, and then the bug triggers, and his response that he got, it never gets out of the server. Possibility number one. Possibility number two is that, his internet gets disconnected. I mean, it's a server, but, still, you might have some mishap or some other process that is eating all the bandwidth now, and, and his reply never gets out. The third reply is that my internet goes down. So, there is no way in which I can essentially make sure that if I tell him $12.98, his response is recorded once and once only. This doesn't work. If you try to do a protocol in which you account for expenses by sending them one by one like this, it will mostly work, but you will have missing expenses and double counting, and there is just no way around it. So how do you do it? The way you do it is something like this. There are many ways of doing it, but a typical one, so the typical idea is this. Together with each expense, you assign an ID. For example, AB7F. D8G1. This ID can be a timestamp, or it can be a randomly generated ID. You don't really care what it is, okay? But by this simple trick of assigning an ID, you essentially solve the problem, because instead of communicating change, hey, I spent $12.98, now you communicate state. You have a list of expenses, okay? And you do a very simple protocol. Instead of sending him my changes, I spent $12 more, I simply tell him, hey, this is my list of last expenses. He gets it, and he says, oh, these I know already, these I know already, these I know already. Oh, this is a new ID. I mark it, okay? And he replies back to me, not with an okay or not okay, but he replies back to me with his list of expenses, so that I can check, does he know them all or not? Of course, if you have too long list of expenses, at some point you can check and say, fine, the expenses up to the day before yesterday all coincide, so now I'm going to send him only the ones that are after that. You can essentially shorten. You don't need to repeat the history from the beginning of time necessarily, right? So once you have some sort of big enough scope, you can only send a newer part. But essentially, what we are trying to do is communicate state, okay? And so is this clear why the idea works? There is no double counting, and there is no guarantee that the expenses are recorded, obviously, right? You can never get such a guarantee because, messages can get lost. But you get another guarantee, which is the best you can get. That is, if you try and try and try, eventually, if some communication happens, eventually you converge to a shared state of knowledge. And so this is the same we do in tic-tac-toe, okay? We don't know that our moves immediately will register on the other end. And in fact, all we know is that eventually we reach a state of shared knowledge. And this, by the way, is a design mechanism in general in software that saved my life multiple times when designing complicated systems. So a principle that I found incredibly useful, and I don't know why, nobody taught it to me, but I think it's common knowledge. It must be found in some books on distributed systems or so, but it's, I call it small amount of useful progress. That is, often when you design a complicated protocol between pieces of system, you start to think, oh my goodness, now that I get this message, and I have to send this message, how do I make sure that, all possible kind of things go right and everything is in sync and this all works, etc., etc. And sometimes that's an incredibly difficult problem. You're trying to synchronize a state of very different objects, and you try to make sure that your logs and whatever else, For example, suppose I'm trying to tell him something important, then I try, and if I don't receive a reply, then maybe I should try again, or should I get desperate and tell him to tell him, or other things, etc., etc., no? And then you get into sort of conniptions about all the various crazy things you can try in order to try to make your system more reliable. And often that's a bad idea. Often what you should think is this: let's make sure that the main actions of my system all do some amount of progress towards, towards the common goal, towards having, for example, all the pieces in sync. Let's not worry about solving all the problems. The goal should be that if you keep trying enough, and if frequently enough communication succeeds, or recovery succeeds, then you achieve the status, okay? But you try to solve a much more local problem. You don't sprinkle in your code lots of retries and lots of retries for all the situations. You may have one general mechanism that retries periodically to sync or retries periodically to bring things to a sane state. And beyond that, you keep your code simple, you do not worry, and you just make sure that it's possible to actually reach a consensus state if communication happens often enough between the various participants. Okay? So that's a very useful design principle because it keeps your code simple and it sort of gives you a simple guarantee that you can actually understand on why the thing will work. Okay? So this is the general spirit in which we do this tic-tac-toe, okay? We won't be waiting for complicated acknowledgements. We won't be waiting for complicated stuff. We will be sending back and forth the information we think the other person should have, okay? Yeah?
Is it possible to have a conflict when those two lists are merging?
Yes, it's possible. And so, in fact, while I'm working to the class, I mean, it's not really a joke. It's something about, that's sort of a real-life inspired joke, right? So the situation, I mean, I'll need your help to watch out for inconsistencies. What can happen is this. I believe that the chessboard is like this. Now, I talk to him, and he tells me that the chessboard looks different, okay? At that point, I mean, we are sending state. So if I do receive the state, I will have to essentially believe that the latest I receive is the state, okay? We will see that there is one exception to it, and I want to see whether you find it while I write the code, okay? So there is one trap that I will try not to tell you, and I want you to try to figure it out while I write the code. But essentially, that's the idea. The joke that came to my mind while I was driving here is that, that's a little bit like, and I mean, that's perhaps a good way to understand it. It's a little bit like life in a family. Like, you want to reach consensus state. You don't want to you don't necessarily know that you have the best consensus state or that your consensus is right. You don't care. Reaching consensus is a superior goal. It's as if you're driving home and you're thinking, oh, tonight, I'll cook this particular dish. Once you get home, you find everybody ready to get out that says, no, we want to eat out at a Korean restaurant. And you just have to drop everything and say, okay, fine, let's go out to Korea. I mean, that's the new consensus state, okay? And so the algorithm I will write will privilege essentially reaching consensus. It will not try to quarrel with the server. No, I'm right. No, you're wrong. Okay? And so it is inconsistent and it is open to attacks in that way, right? And I think, if we had a problem of having some untrusted mobile apps that try to cheat at tic-tac-toe, okay, we would have to worry about it. But in general, there is not so much you can do, right? I mean, you can do something like this, for example. If I mean, this is a general mechanism that is very, very useful to do, but suppose that when you start playing tic-tac-toe, each one of you has a key. It's just a random string, okay? And then I sign all my messages with this key. Do you know how to produce signatures? You take a string, you take a key, and you compute the hash of the two. And then you send the original string and the signature. And so the other person can verify. You know these all, right? I guess so. I mean, it's sort of security 101 or 001 or something like that. You do it all the time, something like this. So let me write it a moment. So what you do is this. I mean, I could try it with a computer, actually. Well, why not, in fact? I'll show you how to do it in Python, because in Python I know it by heart. You do something like this. Yeah, this font is really super small. Bigger. So if you install Anaconda Python, you have IPython that is available with which you can play easily. So once I'm in IPython, I say import hashlib. Okay? Now I can say h is equal to hashlib dot, and I forgot what. Okay, SHA-256 of my key, which I forgot to define. Sorry, I'm a bit silly. Let me write. Key is equal to yada, hello there. Okay, so this is my shared secret. Okay? Then I can say my string to encrypt is, for example, I love cats. Okay? Now, imagine that this secret key is already pre-shared. And now I want to tell you that I love cats, and I want to essentially tell you that it's me telling you that I love cats. It's not somebody else impersonating that is not part of my app. I mean, it's a very simple example. Then you can say h is equal to hashlib SHA-256. I don't know. You have various things that you can do. But for example, of key. So I initialize it with a key. Okay? Now I say h dot, and I forgot all the methods, okay? But h dot, how it is called? Put, add, update, s, no? And then I say h dot hex digest, for instance. You can ask for various digests, and this will spit out a long string, okay? Now, when you get I love cats, if you have the knowledge of K, you can repeat the process and you should be getting the same string. Okay? So what you send is a message made out of, my message is a pair that contains S and H hex digest. Okay? This is my message M. Or I can do like import JSON if you want a string. And I can say JSON dump to a string my message M, okay? So this would be my message, right? It contains what I want to say and the random signature. The key is never transmitted, okay? When you get these, what do? You take I love cats, And you do exactly what I did, right? You take my string, the secret key, and then you do this process again. You get again a hash and you compare it. Is it equal to my hash? If it is, you are sure that it was me or somebody with a key who sent it. If it's not, then it's a fake. Okay? So the problem here is to keep the key secret. But if you manage to keep the key secret, you can send messages so that you know that they have been authored by somebody who owns the key. Okay? It's a very simple principle, but you see it all over the place. All over the place. This is done. Okay? Now, if you work in the cloud, this is super effective because, if I put applications in the cloud, it's very hard for you to get the key. Because the key is in the cloud, and unless you break into my cloud server, you don't get the key. It's a little bit harder to include keys in mobile apps. Okay? So there are various strategies. I think I want to talk about those another time. I mean, one is just to write it in and hope nobody disassembles your code. Okay? Another one would be to, I don't know, require you to log in socially via Twitter, Google, Facebook, something, and then when you prove to the server that you're logged in, then I give you a copy of the key, so at least, yes, maybe a bad guy who now has the key, but at least I can know who that bad guy might be. I don't know, I mean, it's harder to do these things if you cannot trust at all, who owns the other device. But so in this way, you can... in this way, I mean, imagine that you're really doing a backend for playing tic-tac-toe, and one problem is that anybody who is even not connected to your app can start talking to your backend server and playing tic-tac-toe with people. And so you need to decide, essentially, do I call this a feature, and I advertise it as a cool API for playing tic-tac-toe that is available to the world, including the cell phone? No, I mean, that's one choice, to simply decide that you let it open and that's it. Another choice is that you do not want it to be open to the world, and then you try to sign the thing in this way so that you try to talk only to your clients. And, there are other ways. For example, you could require people to pay so they can connect to a cloud server, pay, create an account, then you give them a special key to play, and then you can essentially monitor who has the keys and who is authorized in various ways. Okay? Now, back to the regular programming. Where was I? What was I trying to do? I forgot. Okay, so how do we play? I don't have great ideas on how to connect people, and so I did something a little bit naive. Okay. That came from one time that I wanted to try battleships in a car trip, and all these protocols were complicated. So what I decided is the following, okay? When you start playing, and this can be improved in many ways, okay? But I let you to improve it if you want to do a project in which you play multiplayer games or these kind of things. What I decided is a very simple thing. When you want to play, you need to choose a secret word. I don't know, toasted banana, whatever, right? And you tell it to your friend. Once the two of you choose the same secret word, then you can play against each other. So pairing each other is not done by my app. You could, of course, do it in the app if you wanted, right? You could ask for a list of people. You could choose your own nickname, then send to the server the list of people who are available to play, and then pick one out of the list, right? I mean, you could do it more sophisticated. I didn't care for that. There is only so much time, so I wanted to care essentially on the game playing more than on the matchmaking. The matchmaking is kind of a little bit easier, perhaps. In any case, this sharing of the secret word works pretty well, really. Because if I want to play with, say, him, and he's my friend, I might as well send him an SMS, hey, let's play naval battle, use the word, crazy professor, and we play together using crazy professor. I mean, it's much easier than tell him, hey, go to the list of people and look for the people my nickname is. I mean, who cares about that, right? It's much easier to invent a word. And, you could expire words after some time. You could very easily, concatenate magic words with the timestamps, and, so that if somebody uses magic cat yesterday, magic cat today is still available. Okay? So, long story short, here, where I draw my screen, I use Vue, obviously, and I have this vModel magic word, okay? I have a placeholder string that says shared magic word, and I also have a button that you cannot see because it's scrolled here. Maybe I should just break the line. I have a button that's to set the magic word. Okay, I don't wanna talk to the server each time you type one more character. I let you write, and when you touch the button, I'll talk to the server, but not otherwise. Okay, so you can play with your magic word. So that's fairly trivial, and you see in my Vue I have a magic word and I have a chosen magic word. Why do I have two? Well, the magic word, as I told you in Vue keeps in real time the correspondence between the input content and the variable inside Vue. But I want you to, I want that if you mess around with the magic word but without pressing the button, I don't want you to change it. Okay? And so I keep the magic word that mirrors the input field, and the chosen magic word, which is the one you have chosen and then going to send back and forth to the server. Okay? So there is a my role variable, which I haven't yet cared about making it work, and then there is a board, which I even forgot to fill in. Okay, I think here I would have to add some code that says. I mean, it is very similar to what you have done for the game, no? But it would be something like board of what? Of I plus j times 3. Or I times 3 times j, boo. I don't know. Something like this, Okay. So this is it for this code. And we will need other stuff on the screen, okay? But I'm just building this game as we go, okay? Now, what kind of backend server do I have? So I built one already. I'm hoping you will not, if you want to take revenge on me, I guess you can just work a lot on the homework and, exhaust my money. I'm only partially kidding, actually. So there is a URL. I'm sorry that it is so incredibly small, okay? But essentially you have two methods. Let me describe them by voice. I'm sorry that I cannot make it larger, but essentially there is a write method and a read method. I can say write, and a write has two arguments. It has a key that I mean to be the magic word, right? If we use banana to communicate with each other, I can say the key is banana, and the value is, I don't know, giraffe. Okay, so now I'm writing a string giraffe in the key banana. Why? Hold on. Let me look at my own code. Store, right. I don't know. It was a stupid choice on my part. Maybe I should change it, but it's called store. Store and read. I might have been thinking at these old calculators. I should have called recall it then, if I pretended to be a pocket calculator of the times gone by. So I can store it, and it tells me okay. Okay. And now I can read for a key banana. I can issue a read key is equal to banana, okay, and it tells me that the result is a giraffe, okay, and if I read for a key that is a banana split, okay, I get result is null. So, there is nothing there. It never complains. So essentially, this backend, I wrote it in an entirely generic way so that you can store and read from it whatever you want. And you are free to design your own data structure for the homework, okay? Essentially, the idea is that you can invent what you want to send back and forth in the game. You have to invent what the state is. You translate it to a big string using JSON, you write it with a post, and you read it when you want, okay? And so that's what I do for the code even for tic-tac-toe. I do exactly that, okay? So we have to decide a little bit what is the state. And so what is the state for tic-tac-toe? So there is a player that is X. There is a player that is O, and then there is a board. And I essentially want to send these things around. And, I haven't written the game because I wanted to keep it a bit open to you suggesting. But my thought is this. Tell me if you think that I'm wrong. My thought is that if I tell you who is X, who is O, and the board, I don't need to tell you the turn, because I can do the following trick. I can count on the board the X's and the O's. If there is an equal number or greater of X's, if there is an equal number or greater of O's, then it is X's turn. Otherwise, it's O's turn. So I don't need to keep one more variable around. That is the turn. Okay? In naval battle, you might well want to keep the turn around. But you see, there is some advantage, like in databases, in not keeping redundant information. If I keep both the turn and the board as official portions of the state, then if I make a mistake, it's going to be hard for me to decide, do I trust the turn as computed from the board state, or do I trust the turn as part of the state that I get? What do I do if they arrive in an inconsistent way? No? Since in this way, I sort of avoid having one more degree of freedom that I don't really need. Okay? So that's my idea. The other thing is, how do I distinguish me from you? I mean, that seems obvious, but so how do I do that? Well, I use a very simple trick. I want to make a very lightweight app in which I can play tic-tac-toe without signing in or anything, right? So what I do is this. I have, and in fact, this is part of the starter app. You may have noticed that I give you some JavaScript that is called random string. That JavaScript produces a cryptographically safe random string for you to use. So I'm using that JavaScript so that you can extract a random string and call it your identity. Normally, I would do something more, and I would tell you, okay, now that you have this random string, store it locally. Because if you store it locally, then even if I shut off the app and put it in my pocket and open it again, I'm still the same person. In this case, I'm not telling you, in fact, I'm telling you not to store it anywhere. It has to be a volatile variable. Don't store it in local storage. Why not? The reason is the following. When you develop this app, you want to be able to play against yourself. It turns out that in Cordova, it's very easy to do that. You simply take two terminal windows, and you say Cordova run browser in one, and you say Cordova run browser in the other, and Cordova is smart enough to run it from two different ports, two different browser windows, okay? And so if you don't try to use global things of the browser, like, file system storage or local storage or this kind of stuff, if you don't do that, then there is no problem. The two different browser tabs will behave as two different players, and you will be okay. Okay? So there are many ways of launching twice the application. If you work in a Unix-like system, you know that you can give a command with the ampersand, and this executes it in the background. That's a good way as well. You know these kind of things, right? Just curiosity poll, how many of you have a terminal on which they know that they can write this kind of commands to control the processes that are running in the background? For example, you can say, I don't know, Cordoba run browser, and at the end you put an ampersand, and this will background the command. Raise your hand if you have never done such a thing, to background the process. Okay, wow. I think we really need at some point in the curriculum some class that teaches you how to do this sort of, nuts and bolts of Linux or Unix. Essentially, let me just show you the difference. Just 1 second, so that you know for this command. So, what is a command that is good to background? Can anybody? No, but what is a good thing that I could try to send to the background? It's stupid to send IPython to the background, right? What is that? No, okay, fine. I can run Cordova and try to send it to the background, okay? I mean, it will probably break my code because I'm in the middle of writing it, but... shoot, one second. So, I can say Cordova run browser. So if I do this, the command is running, but is attached to the console. So the console continues to... so now I cannot type anything else, for instance, okay? So this is cleaning it, is doing it, is launching it, and here I have it, okay? And this is still attached, so if I type a Ctrl-C, it goes there and it kills the process. If I instead do this, the process will be sent to the background. So I can still do a file list. You see? It's sending the output to the same console, but it's running in the background. And if I ask PS in the list of processes, I see it. And in fact, I see that I have too many Cordova. Okay? I have too many node processes. And so I can kill all node. And this will kill all my node processes. Okay? And should free up a lot of space. Right? So we should... I wonder, we are likely to see... No, my memory usage didn't change by very much. Evidently, they were efficient. Anyway, so you can, if you don't know how to do these things in order to run it twice and send it both times to the background, you can just run it into different windows, into different terminal windows. If you don't know how to get to different terminal windows, then you're in trouble, officially. Okay? Okay, let's continue. So, let's look at what I wrote as far as the code goes. So I give the server URL, and most of the other things are... so I have self my identity. Why do I assign things to self instead of just saying var my identity? If I assign them to self, it will be easier to inspect them via the JavaScript console, because then I can say app.myIdentity, and this is pretty useful. So I say self my identity is equal to a random string, and then I create a null board just because I'm lazy and it will be convenient many times. Okay? And my main idea is the following. I mean, the rest is boilerplate. And here begins the code that is sort of interesting. So I want to keep a variable called self-state that corresponds essentially to what is on the server. So I want to mirror back and forth this state. Okay? And so I want to keep these various pieces of information, the identity of player X, of player O, and of the board. Okay? Are they called player X and O, or are they called player X and 0? I don't know. O is fine. Okay, so that's what I plan to ping-pong back and forth. The other thing that I want to do is this. You can do it in more sophisticated ways, okay? And I can tell you a moment what the various options are, but I'm going to do something pretty simple. I'm going to ping the server at regular intervals of, in this case, I put it to 2000 milliseconds. That is 2 seconds. Every 2 seconds, I'm going to ping the server. That's why you will break my bank, okay? Because every read costs me money on that cloud. And you're 260. So when I ping the server, so there are 2 ways of doing these things, a regular ping in JavaScript. There is a set interval function that calls repeatedly a function every 200 milliseconds, every 2000 milliseconds, so every time you want. I'm not using that, okay? Because the problem is that I don't want to do things actually every 2 seconds. I want to do things at a 2-second interval after the previous thing finishes. The thing I'm going to do is that I'm going to ping the server, get the answer, and possibly do a little bit more computation after that. I cannot be sure how long it takes for me to get an answer from an HTTP call. If I have connection and the server is there, it will usually take me a fraction of a second. If I'm going through a gallery, if I'm in a place with no reception, the thing will time out only after 30 seconds. And I don't want to keep issuing one read every 2 seconds so that I have, 15 outstanding reads, which is what would happen if I send reads every 2 seconds. So what I'm doing is I'm writing a piece of code that has this general shape, okay? I have a function that is called callServer that does things as follows. It logs that I'm calling the server, and then it has a very simple loop, okay? If I don't have a magic word that is chosen, I actually don't do anything. This is because, I can only call the server to sync the state, and we sync the state based on the same magic word. The magic word is a secret word that you share with your friend, right? So if I don't have any chosen magic word, I cannot sync the state in any case. It's completely pointless to call the server. I wouldn't know even what to read on the server. You read the server, you do the read for the magic word, for the state associated with the magic word, right? So if you don't have one, you cannot do anything. So if I don't have a magic word, I simply don't do anything. Except that I say that I will do another call server after my call interval. If I do have a magic word, then I do an AJAX call. The other times, we have seen that we do $.get, I think $.get was the main one for reading. And you may be wondering, or get JSON, right? You may be wondering, why don't I do a get JSON? It's because $.ajax is a little bit more general. And so I do it by saying that the data type is JSON. This will get me essentially the same behavior as a get JSON. But I say, and we will get to the other fields later, but I say that once this is complete, so either if it succeeds or if it fails, I don't care, but after this AJAX call is complete, I schedule myself again after again 2000 milliseconds. So that's the reason I'm not using get JSON, because I want to have access to this complete method, which is very handy, is a sort of catch-all. Once this is complete, either whether it goes well or bad, I don't care, I schedule myself again. This guarantees essentially that you run with the 2-second intervals from the completion of the previous call. And if I haven't done something silly, this should work, okay? I haven't tested it yet, but I believe it should work. So the call per se is simple. I call the server, I say that I want to read, okay, and I pass it a data that as key has, my chosen magic word. I get back some data back, okay, and so the data that I get back, in case of success, I call this function that is called process server data. Process server data is where most of the stuff happens, and I'm not writing it in perfect style, but I want to tell you what I wrote so far. You're free to improve on my style, okay? Oops, sorry. Okay. So, the first thing that I'm trying to do is the following. I want to make sure that both players join the game. Before, I can't really do very much. No? So remember that the state has these three pieces. There is player O, player X, and the board. So I'm asking, if I don't get anything in the result, because nobody has used this magic word yet, this is quite possible, right? Then I say that I want to be X. I mean, you could randomize if you wanted. In this case, I say I want to be X. So I say, self-state player X is equal to my identity, self-state player O is equal to null, because I'm not playing with anybody yet, if I got back the empty state. And the board is the empty board, and I call self-send state. So essentially, it's as if you had a blank sheet of paper for the two players. Have you ever gone to play tennis where you can sign yourself up, and when somebody signs up, you go to visit later and you find, tomorrow at 3 I play against Joe, and then you play against Joe. Some clubs work in that way, right? So this is similar. You're writing your ID there, and you're waiting for the other person to also write their ID. No? And so send state is, by the way, entirely trivial. Send state tries to do the following. It calls a post to the server with a URL that shouldn't be right. It should be store, actually, right? Store. And it writes with a key the magic word and the value the state. And I think here I'm being silly because JSON stringify of the self state. Okay, I think I need to do this. Okay. You should try to help writing this code. I assume it won't work, but I assume we can fix it and make it work. Okay, so great. So by the way, notice that I send the state to the server. I'm not waiting for acknowledgements or anything. This is my principle. Do a small amount of good work. I already know that I have one mechanism to keep things in sync. Every 2 seconds, I'm pinging the server. So after, what I do in response to this 2-second loop, I just need to try it once. I don't need to care if my reply to the server fails. No? Whatever. Let's look after 2 seconds. The world will be different. Maybe we'll get connection and maybe things will start working. But I don't worry otherwise. I don't try to catch errors in any other place. I just have one repeat loop. That keeps my life simple. Okay, and then I have to say, okay, I wrote this function. I'm not sure it was a great idea, but I wrote, if it's not true that are both players present, so this means if one of the two players is absent, okay, then I update the state, okay, from what I received, okay, and then I started to say, well, if I'm one of the two players, and the other player is not present, then I cannot do very much. So maybe this is a bad implementation, and so maybe, not per se, right? But is other present is equal to false. Maybe I want to keep this variable in Vue so that I can alert the other user to when your opponent has already signed up or not. Okay, so So I just want to have a general call. I don't want to sprinkle my code with. I want to put in a single function all these updates to these various flags that we will see. Okay, so I can say self-update local variables is equal to a function update things like self who is other present etc. etc. Okay, so we will see later whether we want to compact this code more. Okay, so otherwise this means that we are not present. Let's join if we can. Okay, and so I want to say if the player X is null, then we want to be X, and so we do this. I don't know. This is getting boring, right? So let me do this in send state. I can always call it here, so I don't have to call it every time I send the state. Anyways, okay, it makes my life easier. It's idempotent, anyways. You know what idempotent means? That if you do it twice, it has the same effect as doing it once. So my do you study these things? I think so. So if we have X, we want to be X. Okay, so we mark us as X. If we want to be O, we want to be O. And if O is available, then we write ourselves as O. And otherwise, okay, and this could have been better done there, but self update local vars, okay? And we don't send back anything because it means that other people have already taken our magic word, okay? In update local vars, we can do things like there is a bit of repetition of logic, I guess. Okay, fine. Let me leave this line there. Okay, so we need to be able to give to the user a flag that says, warning, this magic word is already taken. This is how we see it. You choose banana, somebody else is already playing with banana. So you send up to the server reading the state of banana, and I see that instead of Luca, there is George and Henry playing with the magic word banana. And at that point, I can see that I cannot insert myself as any of the two players, right? And that I'm neither of the two. And so at that point, we have to have some icon. And so the way to do it is that, there is a new magic word. Here, after the button, we can have an icon, who if is equal to need new magic word, okay? And the class is equal to fa warning, okay? So this will tell you, you can choose a better icon perhaps, but this does the job quickly of telling you that there is something wrong with the magic word, and so you should try another one, okay? Great. I don't know whether it's better to put the icon after the button or in the button itself. I don't know. You decide. I don't care. Okay? Great. So at this point, if you're not in this else, this means that both players are present. Okay? I organize these if then else's in a stupid way, I have to acknowledge. Okay? So I mean, I'm repeating this if then else in a horrible way, okay? So you can officially say that your teacher sometimes writes a really poor code, okay? But, so if it is not true, if it is, if it is true that, that these are both different, right? So if this is true, we're intruding in a game. So we again can write self who need magic word is equal to true. Okay, and we can say self update local variables, whatever it does. Okay. Else. Okay, and so here is the interesting role, interesting code. Okay, we are playing, and the opponent is there. Okay, so what are we? Okay, I'm writing this code as if like a chicken write code in this way with this sort of if then else nested, I guess. You should really reorganize it, but who cares? I mean, let me just carry on. So, what are we? Self my role. So, if okay, self state play row is equal to self my identity. Okay, so if this is true, I don't know why I wrote two parentheses. But if this is true, then self my role is equal to x. No, all right. Else self my role is equal to x. Okay. Self update local variables, whatever that does. We haven't decided it yet. Okay. So it's not super clear to me that I need to do anything else. Well, I mean, have I already copied the board? So this code contains a couple of problems. Let's see who can find at least a couple of them. I mean, it kind of works, but it does some funny thing on the side. Can you see it? It's related to that assignment, actually. That's what I was looking at. Yeah?
I think there might be a syntax error on like line 104. In that else if statement, is there supposed to be a triple equal?
Oh, yeah. Yeah, that's true. But it's not the error I was mentioning. You're absolutely right. Yes. Thank you. But yeah, you're right. But there is something more sort of silly that I did. Anybody sees anything? So one of the silly things I do is this. It's that assignment that I had overlined or emphasized here. Self-state is equal to data result. You see, the problem of doing this is the following. That I'm essentially writing the state before I know that I'm allowed in the game. So if I know that you and him are playing with a banana, and I write banana, I get your state, and I can see what you are playing. which is not okay, actually, perhaps, right? I mean, I should be seeing the state only if I am in the game. So I wrote this code in a kind of silly way, okay? I should really do a bit better than this. So how to do it? Well, a stupid trick that I can do is this. Well, I don't know, okay. Again, I'm writing very bad code. So, probably you think that, I mean, there may be people who write better code than me, but maybe you would think that, I write and I have the clean code altogether. But whenever I give you a clean piece of code for starter homework for a code, you have to think that I generally don't write it clean necessarily. I mean, in some cases, yes, if it's trivial, but otherwise I actually spend a lot of time rewriting my own code and refactoring my own code. Yesterday, for instance, on another project that I'm doing, I was writing a sort of, I'm writing a sort of storage backend for some Twitter listening client that does this and that, okay? And I spent probably 2 hours of my afternoon writing the same 50 lines of code, and I probably wrote them 5 times. In the end, I deleted a bunch of code, etc., because never was I satisfied with the way it looked. I mean, there are some pieces of code that, you simply keep writing and writing until you polish them enough that you kind of like them, okay? So this code is really bad. But I don't know, I think it's more entertaining for you if you see the process of writing it than if I just present you a bunch of code that is already written. So this might work. So we can display the board to the user. So, speaking of board, does anybody see a little bit of I mean, will this work? I mean, what can possibly happen? Maybe it works, okay? I'm not saying that it shouldn't work. But for example, when is the board cleaved? If I play banana with him and then I play apricot with her, when is the board cleaved? Okay? I don't think I have written that yet. Okay? And actually, I think this is a bad idea. Okay? I think this is a completely bad idea. Self-state is equal to data result, I think was the best. So one thing that really helps when you write the code is this. This I was taught, I mean, I think everybody should know it. But I was taught this especially some time ago when I was working on software verification. When you write code, it helps to have invariants. Invariants are simple statements that are true throughout your code. Okay? So, let me proclaim the following invariant. That might not be true for this code, and then I'll hammer it so that it becomes true. My invariant is that I want that self-state corresponds to what I get from the server, unless there is a super good reason. I'm not saying that it displays it corresponds to what is shown. Notice that self-state is not something to which Wu has access per se. So I'm not saying that I display that, but I want to have a simple model of the world. Otherwise, I lose my mind while I write the code. And so I want self-state to be what the server thinks and what I should think. Whether I should display to the user or not, that's another business. Okay? And I might devolve it entirely to these update local variables. Okay. Also, this place the board whenever I am part of the game and blank otherwise, which is an ungrammatical comment, but conveys the feeling that essentially I want to delegate to this function the fact of choosing whether to display the board or not. It's a very easy decision to if you move it to that piece of code, right? If both players are present and I'm one of the two players, show the board on Vue, otherwise do not. But otherwise keep a self-state corresponding to what you got from the server, otherwise you go nuts, okay? So this should be a better way to write the code. And so, and so in this case, these couple of lines here, I just wish it was easier to, okay, it can be eliminated. Okay? So, now, what do we do when we actually play a move? Okay, so do I need to do anything more when I get something from the server? I don't think so, no? I think that's all I need to do. Right? So I think that the other thing missing is that I can't really play. Haha, small problem. Okay, so okay, so the send states are here. Okay, so now I need to be able to play. Okay, I have initialized my role. Maybe I should have some other variables. This is where I waste time. I should decide whether I should have a variable that says, the game is on, right? And I would prefer to have it as a derived variable that say update local variables fixes by looking at the state, right? So that it pre-computes this sort of silly bits. In fact, let me essentially do place markers, okay? That says self Vue board is equal to null. Self Vue is game ongoing is equal to null. I mean, these are null, but when I replace them, with the appropriate code, it's only that this code is trivial but boring to write. Self Vue, what is it? Is game ongoing? Okay, self Vue my role is equal to null because I want to display what you have somewhere on the screen, whatever. Okay, so imagine that here I write the right logic. You see, it's kind of obvious to write what the logic is. Okay, and there is another variable that says my role. I mean, my role I have computed it already, but I also want to say self Vue is my turn is equal to false. So, I want to have a variable that tells me whether it's my turn or not, obviously. Okay? So these things are stupid to compute. For my turn, I told you already that you count the X's and the O's and you decide whether it's your turn or not. So this can be done. But how do we play? How would you play? I mean, we don't have anything that lets you play. How would you implement playing? Suggestion, yes?
You would use some functions for each CMP, and depending on if you're player X or player O, it would display an X or an O in that font.
Yes, so what she's saying is quite correct. So we need a Vue click now, and so let's write the Vue click a moment, and let's try to see the logic. So here now, in this TD now, when you click on the inner TD, I guess, so Vue on click is equal to play. Just to give it some name, okay? Oh, play of IJ, I guess. So let me fill it in here. So I need a play method. Play, self-play, and self-play is equal to function ij And one can fill in the details, but what is that we have to do here, basically? We can write it in comments. Actually, that's what I always do. We can write the comments first and then fill in the code. The code is easy to write once we know what we have to do. So let's just fill in the comments. So we have to, change so we have to check that the game is ongoing and that it's our turn to play. Okay? Then, because if this is not true, we don't do anything. Okay? Because you can touch as much as you want, but then we have to modify, update self VuBoard and self state board. Okay? We have to update these two that reflect the state. And then we have to call self send state, which sends the update to the server. Okay? Yeah.
Should you also check if there's already a play on that?
Oh, yeah. And yeah. Check also that the square is empty. Okay? You have one more?
Well, so in the 15 puzzle, I know when we assigned the color to each block, we actually had to pass in the element, not the IJ coordinates, because then the board wouldn't update. I don't know if you remember.
Yeah, no, but I don't think it's true. I mean, what you do is a VU set, no?
Yeah, it may have just been because that's what we were doing, but when you decided whether to color a square red or black.
No, I think that was done with the conditional classes. I mean, that's the best way to do it. I'm giving away part of the homework, but this is what I did in my suggestion, right? I have a VU bind class, VU class bind, what was it called? That essentially, VBind class is equal to, and there I had, for example, color red if the content of the cell, if the indexes ij are, if the content of the board ij was smaller than or whatever. But I don't know. Here you don't need to do it anyway, because you just need to fill the board array and that will change the content. No, there is a more fundamental problem with this code that I won't tell you because we are out of time and because it's amusing. So I'll make it work, okay? I'll make sure that this works. So you can also make sure that should I make it work or should I leave it? Well, I don't know. What should I make it work or should I leave it like this that is half broken?
But thing I'm thinking
yeah.
Is that once you take a magic word and then you stop using it, like you close the app, the magic word will still be taken.
Yeah. That's a problem. And so we should do something about that. But that's a problem that I'm not going to solve, okay? No, it's not true. Think of a solution for next time. I would love to solve it and have magic words expire. We could concatenate the day to every magic word. That would be a simple solution, okay? I just don't want to implement a solution that involves a server or is complicated. We could include the day, and if people play over midnight, that's bad for them. There is no super good solution, the problem is. The solutions are complicated. You need to keep a timestamp, and you need a bit of help from the server to do these kind of things, and I don't want to focus the homework on that so much. But there is a more basic problem related to the way we talk to the server in what we have written so far. Okay? And so think at it. And so I don't know, would you prefer me to make this code work for next time, or would you prefer that I put it as it is on Git and you have a bit of the challenge or amusement to try to make it work for Thursday in a collaborative way? Nobody wants to collaborate with me when it comes to doing. Okay, fine. I'll ask the TAs. that volunteer. No, we will see what to do. But thank you very much, and see you Thursday.